Welcome back to night 2 of polynomial division. Tonight we're going to talk about a shortcut. However, a word of caution. This shortcut only works sometimes. How do we know if we can use the shortcut? Well, our divisor has to be 1x to the first power. If it's anything other, let's say 2x minus 7 or 3x plus 1 or x squared minus 6x plus 2. Okay, any of these, you cannot use this shortcut. Otherwise, if it's something like x plus 3, x minus 4, x plus 1, x minus 8, etc., those are all 1x to the first power, and you can use this shortcut. I'll let you go ahead and read through these steps. The biggest thing that I'm going to point out is that, again, we have to be dividing by a polynomial that's 1x to the first power. The other hugely important thing is to make sure that the number that we're dividing is in standard form, and all exponent values must be represented from your degree on down to no variable. The best way to learn these steps is to actually do them. So let's go ahead and give these two examples a try. So I'm looking right now at the x minus 3. Is that 1x to the first power? Yes, it is. So we can use our shortcut. Then I look here, I have x to the third, x squared, x to the first, no x. So this is in standard form, and all of my exponents are represented. To start our problem, we're using our x minus 3. Now remember that x's are liars, so 3 is what goes in the box. Then we're using our coefficients, or the numbers in front of our variables, and our constant. So we have a positive 1, a positive 4, a negative 5, and a positive 5. From here, we're going to vote the last number off the island. This is where our remainder, if there is one, will be at. And then we always drop down our first value, whatever it is. Doesn't matter if it's a 1, a 2, a 5, a 7, a negative 80, whatever. Always drop that down. From here, I use the 3, and we say 3 times 1 is 3. 4 plus 3 is 7. Okay, 3 times 7 is 21. Negative 5 plus 21 is 16. 3 times 16 is 48. 5 plus 48 is 53. So we know 53 is going to be our remainder. Immediately to the left of our line that we used here, we start filling our variables back in. We start with x to the 0, x to the first, x squared. We keep adding a number in our exponent until we reach all the way to the far left. So that means our answer is 1x squared plus 7x, because that's a positive 7, plus 16. Now x to the 0, that means there's 0 x's there. We just put that in as a filler as we started working our way down. And then remainder, 53 over x minus 3. That is our solution. Now, another way that you know that you've done your shortcut correctly is our highlighter. Our 3. All right, let's try that again. Our 3 is our largest exponent. That's our degree. Your answer should be 1 less than that every single time, as another way to check that you did it correctly. All right, let's try this second one. We again start with the x plus 2. Is that 1x to the first power? Yes. Okay, cool. That means we can use our shortcut. Then I come to this other part and I say, okay, this is a third degree, so I have 5x to the third, 6x to the first, and then 8. This is in standard form, but I jump from a third power to a first power, which means we're missing x squared. You have to add this 0 in. Adding that 0 in on yesterday's notes wasn't that big of a deal. It helped as a placeholder, but you didn't absolutely have to add that. If you are using the shortcut, you absolutely have to add that 0. And so this is my new standard form for the equation. Now I can take my x plus 2. Remember, x's are liars, so we're putting -2 in the box. And then our numbers are 5, 0, 6, and 8. We vote our last one off the island and always drop down that very first number. So then we start. -2 times 5 is -10. 0 plus -10 is -10. -2 times -10 is +20. 6 plus 20 is 26. -2 times 26 is -52. 8 plus -52 is -44. Okay, so we know our remainder is -44. And then starting with this 26, you fill in x to the 0, x to the first, x squared. So our solution to this division problem is 5x squared minus 10x plus 26. Remember, we don't use that x to the 0 power. Remainder, -44 over x plus 2. We will be working with lots more division of both shortcut-worthy and non-shortcut-worthy problems in class the next few days. Thanks very much for joining me again, and I will see you next class.